Hi, and welcome to our next series of videos. In this one, we're going to take a look at software. Now, before we get going, a quick little announcement. For those of you who are students out there watching these videos, don't forget all of these videos, this entire lesson, is free and available on my YouTube channels. If you're an educator and you'd like to get access to the PowerPoints, please be sure to check out teacherspayteachers.com. There you can find my store, Mr. Ford's Class, and you can download all of these PowerPoints for only about $5 each. So be sure to check that out. Your support allows me to continue to make these educational videos. So enough about that. Let's actually get going with what we're going to talk about, and that would be software. If you remember from the previous videos, we talked about the fact that there are two general components to computers. There's the hardware portion, which we've talked about ad nauseum in the previous video. This one, we're going to get nauseated over software. We're going to talk about software. And we break software down into two groupings. We have your system software and your application software. Your system software is the stuff that runs the computer itself. These are the ones that are working with your hardware, your operating system, your utilities. That would be an example of your system software. And we're going to take a look especially at operating systems later on in this video series. Your application software is what gets stuff done for you. It's the reason why you buy a computer, because you want applications to do things, whether it's Word documents or, for example, video recording, video editing, posting. These different things require applications. In order to develop software, we have a specific thing or a certain thing called software development. And there is a great definition on Wikipedia about what software development is. Software development is the computer programming, documentation, and testing involved in creating and maintaining applications and frameworks involved in a software release lifecycle resulting in a software product. What does this mean? Okay, it's a great definition, but what does it mean? Basically, what we're looking at is a methodology on how to create software and release it. And it really has to deal with more or less project management. And you see project management be used in a whole bunch of different industries, and they might change the terms and they might change the steps, but the core of it is there. Most methodologies are going to share some combination of the following stages of software development: your requirements, your design, your implementation, your verification, and your maintenance. Again, from Wikipedia. By the way, Wikipedia is an amazing resource when it comes to technology stuff. Usually, your Uber geeks are posting stuff to Wikipedia first, as far as coming from white papers to Wikipedia. So it's a good resource as far as technology information goes. So software development lifecycle, you have analyzed the problem. Is there a problem? We don't need to make anything if there's not a problem. So let's say that there's a requirement. Let's say that you are at a job place, you're at the workplace, and you have a need. Something needs to be done. There's a new procedure that nobody seems to be able to do. There's no software to do it. So this would be a problem. So you're going to analyze the problem. What is the problem? What's the need? What are people doing now? What would you like them to be able to do? Market research. You're going to go out there and find out, one, if there's anything out there that already meets those needs. If not, then let's talk about the clients who are going to use it. What do they like? What kind of technology sophistication do they have? So you're doing your market research. You're gathering requirements for a proposed business solution, design a plan or design for the software-based solution. This is where you're actually going and saying, this is the problem, this is the fix. Let's design how we're going to do this. So for example, let's say the problem is there's no word processing software. Okay, there's only typewriters. But we need something computer-based to be able to replace a typewriter. So what would we want in this program? We'd want something where you could type and the words would be displayed. You'd want something where you could bold the letters. You'd want something that could outline them, underline them, italicize them, change the fonts. So you are specifying what the fix is. Then you have the implementation or the coding of the software. This is where you people actually sit down and write out the code that's going to create the software which will solve the problem. You're going to test the software. Software is buggy. It's so many moving parts that something's going to go wrong, and so you have to test the software. So it's internally tested, you run it by other developers, you run it by maybe your project manager, you're running it around the office to see what's wrong with it. In fact, you're trying to break it in many cases, which is always fun because you get to destroy it. And the problem is if you can destroy it, there's a problem, and that's where you go, okay, this is a problem, this is a glitch, let's fix this, let's release it. Then you might have an alpha release. Alpha releases are super, super early. You know it's going to be buggy, you know it's going to be problems. Right before it goes to market, you might have a beta release, a beta, B-E-T-A, a beta release, which is everything should be working, but we're not completely sure. In fact, Google has a lot of their stuff constantly in beta versions. They're finally releasing some things without beta, but for a long time, a lot of stuff was beta, like Gmail was beta, Calendar was beta. But that's the beta testing. That's right before you should be getting ready to release. Then you have the gold, which is, boom, we're ready to go to market. And of course, stuff will happen. Even if you've beta tested it, once it gets out to the market, out to all of the peoples out there, something's going to go wrong, and that's where you're going to fix it. So you have deployment, get it out there, and then the last stage, which kind of is a circular thing because it goes back, and I'll talk about that in a second, but you have the maintenance and bug fixes. People will find problems, people will find ways to break the software, you release updates, you release patches. In fact, I had already recorded all of these software videos yesterday. I found out today that the sound went out of sync. That is a bug. And so when I went to Camtasia's website, I saw that it was in fact a bug, and their fix was to record the video using another software and then putting it back into the Camtasia. So that would be a bug fix that, they obviously didn't see during beta testing. Now, as a course developer, as an instructional system designer in ISD, which is what my profession is, we have something very similar. It's called the ADDIE model. Understand basically that all of these professions, computer design, project management, instructional designers, a lot of us have very similar structures in how we develop and release stuff. So for example, as an system developer, as a courseware developer, I have the analysis portion. Is there a problem? What are people doing? What do you want them to do? Can we fix this? How do we fix this? The design phase. This is my proposal. This is the timeline. This is what we're going to do. This is how we're going to fix it. The development. Now we're actually creating the course. We're creating the training. Implementation, getting it out there. Let the people work on it. Let the people go through the training. And evaluation. Is it working? Is it not working? What needs to be tweaked? Oh, hey, there was a typo there. There was a misspelling there. Let's adjust that. And notice that it's circular because it is circular. It's not a one-shot through and you're done. At least it shouldn't be. You're going back to revamp it. And so this is a general idea of software development. Actual creating of software is called computer programming. It's the process of creating software to solve a problem. You might hear us cool kids call it coding. And the people who do the coding are called coders or computer programmers. These are the folks who don't like bright light and drink a lot of energy drinks. They are the computer programmers. They are the ones who are coding the information. And in order to do this, they program via programming languages. If you were ever in college taking, let's say, a bachelor's degree, a lot of bachelor's of arts degrees require a foreign language requirement, or like I had to take a foreign language in high school. I took Spanish for 3 years of Spanish. I took Spanish 1 twice and Spanish 2 once. I took 3 years of Spanish. Yeah, I repeated one of them. You learn a language. And it wasn't just enough to learn the words. So it wasn't like you could just learn hola and baño and zapato. I mean, all these different words. You had to learn the syntax. I never said I was good in Spanish. You had to learn the syntax and the rules on how these worked. And that's what a computer programming language is. It's rules. How do you write this? What kind of spacing do you need? What kind of punctuations do you put? And those are the different programming languages. If you want to go online, let's say to dice.com or monster.com or careerbuilders.com or any of the job websites, if you look at computer programmers, they'll say, jobs for computer programmers, they'll say, must be able to code this way, code that way, what have you. So here are some of the more popular languages available. You have Java, C++, C#, Objective-C, PHP, Ruby, JavaScript, SQL. These are the different programming languages that are very popular right now. There are other languages out there, but these are the big ones as of right now. So if you want to have some fun and you've never done any computer programming, you can give it a shot. try this QB64. QB64 is a free version of BASIC, the old school BASIC computer programming language. You can try this online, or you can download it for free on a PC. If you have a Linux computer, you can download it there, or a Mac. You can have some fun there and give your fingers a chance at programming language. Okay, in the next video, we're going to get even geekier, so if you haven't got your coffee yet, go get some, because we're going to talk about the boot process.